Hello, curious minds. Have you ever wondered how it all ends? Our universe is vast, mysterious, and incredibly old, but it's not eternal. Someday, it will come to an end, and the ways it might happen are stranger than you could imagine. Will everything freeze in eternal darkness? Will the universe collapse into itself? Or could something even more dramatic tear the cosmos apart at the seams? Today, we're diving into the most fascinating theories about the ultimate fate of the universe. Are you ready to explore the end of everything? Let's find out. Let's start with the Big Freeze, or heat death, a concept that dates back to Lord Kelvin, who first introduced the idea in 1852. He posited that as the universe expands, it will gradually decline into a state of maximum entropy, where all energy is evenly distributed and no work can be done. Entropy measures disorder in a system. As the universe expands, energy spreads out more thinly, increasing entropy. Like hot coffee cooling, heat spreads, reaching equilibrium. This process continues on a cosmic scale. As the universe expands and cools, stars burn through their fuel, and the formation of new stars becomes increasingly rare. The raw materials for star formation, vast clouds of gas and dust, become too dispersed for gravity to pull them together and ignite nuclear fusion. Existing stars will fade away into white dwarfs, neutron stars, or black holes. The expansion of space also plays a crucial role. As space stretches, galaxies drift farther apart, becoming fainter and more isolated. Eventually they will be so far away that they won't interact gravitationally anymore, effectively leaving galaxies isolated in a dark, empty cosmos. At the same time, the increasing entropy of the universe affects the availability of usable energy. As energy becomes more evenly distributed, the temperature differences that drive physical processes diminish. This means less energy is available to do work, contributing to the universe's slow decline into a state of equilibrium, a cold, dark, and lifeless universe. The Big Freeze is one of the most widely accepted theories among cosmologists today, predicting a universe where, after trillions of years, nothing will be left but scattered particles in a cold void. The Big Crunch offers a dramatically different vision of the universe's end, one where gravity ultimately triumphs over expansion. In this scenario, the expansion of the universe eventually slows down and reverses, pulling everything back together in a colossal cosmic collapse. Imagine the universe as a giant balloon being inflated, then slowly deflated, with all the air rushing back to the original point. This reversal of expansion would be driven by the gravitational attraction between all matter in the universe. As galaxies draw closer together, their gravitational pull on each other intensifies, accelerating the collapse. This process continues until all matter is compressed into a single, infinitely dense point, a singularity similar to the one from which the Big Bang is thought to have originated. However, current observations suggest that the Big Crunch is unlikely. Dark energy, the force behind the accelerated expansion of the universe, makes it difficult for gravity to halt the expansion, but if dark energy weakens or behaves differently over time, this scenario could still be possible. As the expansion slows, galaxies would begin to move closer together, and their gravitational pull on each other would strengthen. This would lead to an increase in galactic collisions, creating a dance of destruction as galaxies merge and tear each other apart. The temperature of the universe would rise as matter becomes more densely packed, with the background radiation from the Big Bang becoming more energetic and heating up the cosmos. Ultimately, the universe would continue collapsing until density and temperature reach near infinite levels, culminating in the formation of a singularity. The Big Rip presents the most violent and dramatic end-of-universe scenario. In this theory, the expansion of the universe accelerates at an ever-increasing rate, driven by the mysterious force known as dark energy. This acceleration becomes so powerful that it overcomes all other forces, including gravity, electromagnetism, and the strong and weak nuclear forces. As the expansion accelerates, galaxies begin to recede from each other at ever-increasing speeds. Eventually, the expansion becomes so rapid that it overcomes the gravitational forces holding galaxies together, tearing them apart. Stars are flung out of their galaxies, becoming solitary wanderers in the expanding void. But the destructive power of the Big Rip doesn't stop at galaxies. As the expansion continues to accelerate, it eventually overcomes the electromagnetic force that binds atoms together. Atoms themselves would be ripped apart, with their constituent protons, neutrons, and electrons scattered into the vast cosmos. At the heart of this scenario is dark energy, which makes up about 68% of the universe's total energy density. The nature of dark energy is still largely unknown, making it one of the biggest mysteries in modern cosmology. Scientists are actively researching dark energy to understand its properties and its role in the universe's evolution. As the universe expands, the density of dark energy remains constant, while the density of matter decreases. This means that the influence of dark energy becomes increasingly dominant over time, driving the accelerating expansion. The Big Rip is a relatively recent theory. first proposed in the early 2000s. It is based on the assumption that the density of dark energy remains constant or even increases over time. If the density of dark energy were to decrease, the universe might avoid the Big Rip and instead experience a different fate, such as the Big Freeze. The time scale for the Big Rip is highly uncertain, but some estimates suggest it could occur in as little as 22 billion years, depending on the precise nature of dark energy. While the Big Freeze, Big Crunch, and Big Rip are the most widely discussed end-of-universe scenarios, other theories explore alternative possibilities. These less mainstream theories offer fascinating glimpses into the potential complexities of the universe's ultimate fate. For instance, some scientists propose the idea of a Big Bounce, suggesting that the universe could undergo a cycle of expansions and contractions, continuously rebounding after each collapse. This challenges the notion of a singular end, hinting at a universe that might be eternal in its own way. Then there's the concept of vacuum decay, where a shift in the energy state of the universe could lead to a catastrophic collapse, creating a bubble that expands at the speed of light, wiping out everything in its path. This idea presents a more immediate and unpredictable threat to the cosmos. Each of these theories offers a unique perspective on the fate of the cosmos, and as our understanding of physics and cosmology evolves, so too will our theories about the end of everything. In future videos, we'll delve deeper into these theories and explore the mysteries they present. As we've journeyed through the possible fates of the universe, from the slow decline of the Big Freeze to the cataclysmic scenarios of the Big Crunch and the Big Rip, we've seen just how mysterious and complex our cosmos truly is. While we may not yet have all the answers, each theory reveals the intricate dance of forces at play in the universe, from the expansive reach of dark energy to the gravitational pull of matter. The future of the universe remains uncertain, full of possibilities that challenge our understanding of time, space, and existence itself. As scientists continue to unravel the mysteries of the cosmos, we can only speculate on what lies ahead. Whether we face a gradual fade into darkness, a violent tear, or an endless cycle of rebirth, one thing is clear: the universe's story is far from over. And there you have it. We've explored the chilling Big Freeze, the collapsing Big Crunch, and the dramatic Big Rip. But what do you think? Could one of these be the true fate of our universe, or is the end something even stranger? We'll dive into these fascinating theories in a future video. Before you go, let me know in the comments which theory you find the most fascinating. And don't forget to like, subscribe, and hit the notification bell so you don't miss any future cosmic mysteries. Thank you for watching. Until next time, keep looking up.